Alright, so welcome back everyone to our OpenFOAM discussion. So in the last video, we are talking about one possible way to work around this problem of not having these boundary conditions. Let me try and just illustrate what I'm talking about. Okay, 0.0/u. Yep. We find that there's a top patch wall and bottom patch there, but there's no extra boundary conditions called processor 2 and 3 or processor 2 to 3, etc, etc, because that's what the log PiezoFoam will say. You can't find these patch fields entries inside the pressure boundary pressure files, and also that's what the patch summary says. Yep, so you cannot find patch field entry processor boundary 2 to 3. So one way that actually works is that we run all this in series first, and then we run the processor's PiezoFoam in parallel. Of course, the end aim is to run both SnappyHexMesh and PiezoFoam in parallel. That will be completely ideal. But let's do the workaround first. And since we are here, I want to show us the one of the interesting tools in Git, which is called Git Reset. Yeah, what Git Reset does is to just restore everything to the original state. So let's do refined PiezoFoam Snappy Pipe. We're going to remove everything. So let's say you have something like this, and git pull will not do anything for you. Let's see whether it works. So sometimes git pull works, sometimes it doesn't. So sometimes it will show that, okay, I'm already up to date. You are more updated than the master file. So instead of git pull, we can use git reset. And we use hard origin master. That usually works. So do git reset again, -- hard origin master. And then you press enter and see what happens. It's going to check out files, okay. So we are at this point now. So remember, parallel processing, debugging in progress. That's my commit message. So see, my refined PiezoFoam is back, and we look at Allrun Parallel. We are back at a few saves ago in that sense. Okay, so let's run it in series instead of parallel, right? So we'll run the Decomposer Parallel over here. Okay, we want to run the Decompose Parallel here. Then we'll just delete this, and we'll run SnappyHexMesh instead of series. We run it in, instead of parallel, we run it in series, and we will not use this processor. We'll not use this processor thing here. Okay, I'm gonna do touch refine snappy pipe.foam. Run application decompose parallel, run parallel PiezoFoam, and run application reconstruct parallel. Let's see whether this works. And this should work, unless there's some bug. I'm going to put n here. And it's going to clean the case, run block mesh and SnappyHexMesh. Okay, I'm going to fast forward this. Okay, so we fast forwarded it, and it looks like PiezoFoam is running. So let's take a look at the log.PiezoFoam to see whether it's running. And indeed, it's running very well. Okay, so is it running in series or parallel? It is definitely running in parallel. Take a look. Okay, so it's running in parallel across 4 processors. Yeah, and it's running exactly the way we want it. And if we take a look at the processor 0, for example, nothing's been written there yet, so we kind of gotta wait. But all in all, PiezoFoam actually works if we do our SnappyHexMesh in series, and then we run PiezoFoam in parallel. Alright, so let's take a look at the processor 0. And we take a look at the 0 file. And we take a look at each of the files. Now we see that the boundary field, processor boundary 0 to 1 and 0 to 3, are all put there, right? So yeah, this is this becomes, you know, not an issue, because the decomposing was done after the mesh was written properly along with all the boundary conditions. Okay, so we take a look at the Allrun Parallel. So this was actually run. Okay, so we run everything here in series, but only after that we run the Decomposer Parallel. Okay, so that means in the zero file is from zero original, which contains all the initial and boundary conditions, but the files were all written into this constant file before we do the Decomposer Parallel. So there's a log Decomposer Parallel here. Okay. Yep, and it's using the Scotch method, and it does all the field transfers here. So the last time we were trying to do it, Decomposer Parallel was only done after block mesh, and then we try and run everything in parallel, but something doesn't quite work. So okay, perhaps the workflow should be something like this. We know we can run snappy hex mesh and everything in parallel. That is not an issue. But somehow we will need to collapse all this data back into the constant, and then we need to run our Decomposer Parallel again so that PiezoForm can start running. So yep, let's do the workflow. So mesh generation, so decompose parallel, mesh generation, which is the snappy hex mesh and everything, reconstruct, and then after that you decompose again, and we will have the PiezoForm to run, or whatever solver you're using. Then we reconstruct to visualize the data. So now this is roughly the workflow we are aiming for, and this is, I'm not the first one who came up with it. So I mean, based on that, yeah, there's many years ago, so a lot of people had the same problem with the patch field entries, and then all he was doing is that I think you have to this guy Joe Carito, he says that I think you have to reconstruct the mesh, decompose it afterwards again, because the new mesh from Snappy OpenFOAM doesn't know the new boundary faces, which was the processor boundary 0 to 1, 0 to 3, blah 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 blah. So again, you take a look, you try and run snappy hex mesh in parallel, then we have to reconstruct this parallel meshing, and then we decompose again. So that's basically, you know, the idea behind what we are aiming for, right? Because the thing is that from our line of code, we have seen that, you know, we can run snappy hex mesh in parallel, no problem. But because Decomposer Parallel dictionary, or no, not dictionary, Decomposer Parallel, this utility was not run after the snappy hex mesh and create patch everything. You know, the boundary conditions weren't written properly, and therefore PiezoForm could not run. So we'll have to do something about these in order to make sure everything is run in parallel. Okay, so I'm gonna just stop the video here. So in the next video, we want to see whether these 3 applications at least, can be done in parallel by you know, we decompose after block mesh, we decompose the parallel using the Scotch method, and then we run all this in parallel, then reconstruct a parallel like mesh or something like that, and then we run these 3 lines of code, and then we stop, and hopefully it will run properly so that we can run everything in parallel. And just to take a look at the computing space. Yep, a lot of tasks is running, and PiezoFoam is running in parallel. 1, 2, 3, and 4 processes. Perfect. And yeah, so computer's a bit slow because, you know, lots of processing is going on. And I'll put this link in the description below for your information so that you can refer it to it anytime you want. Alright, and of course to give credit to this guy, Jokerito. And that's all I have for you this video. Thanks for watching. If you find it useful, please like and subscribe. I appreciate that very much. And leave a comment if you have any questions or comments you want to leave behind for me. Alright, see you again.